All right, so let's go with that for a problem, see what we get. Okay, let's see what we got here. So find the volume if it's rotated against this. So you don't have to necessarily draw this out. You can if you want, but this is just going to be an arc. And all you need to know is that the setup is going to be pi r squared. And we bring the pi out front. So pi r squared. So once the setup makes sense, this really isn't that hard of a lesson. So, all right, what are we going to do with this? We're going to say it's pi. Let's make sure we do this first because we can. If we take the square root of x and we square it, that's just x. So now we've got something that's fairly easy to integrate. And if I integrate x, I'm going to just get x squared over 2. And we're going to run that from 0 to 3. And I'll just bring the pi down and we'll put that in when we're done. So we good with that being 9 over 2, and then the 0 is going to go away. So I'm getting 9 pi over 2 for an answer, and that's it. We're done. Any questions? Okay, so then let's take something very similar, same directions. I'm not writing them out again, same directions, but now we want to say the volume, find the volume for the following. And we've got now we've got two functions. It's going to say find the volume of the shape when the following functions are rotated across the x-axis. Now, before you start that one, so now if you listen to his lesson on the weekend, it's called disks and washers. Doesn't really matter that you call them that. Disks is one formula, washers is two formulas. And the reasoning for that is, so let's just quickly look at a visual of this. If we were to sketch this graph out from 0 to 1, the radical graph is going to be an arc that's up and over. The quadratic graph will make that the dashed line. That's coming underneath it, and they both intersect at 1. Okay, so now if you were to rotate these, you're going to get this. There's the first one. But now when you rotate the second one, so we'll do one of these solid, one of them dashed. And when you do the dashed one, you're going to get, I'm not an artist here, so you got to bear with me. But basically, there's a hollow spot in the middle of this, right? So it's not an entirely solid object. There's an empty spot in the middle. So think of this as area bounded in terms of a three-dimensional shape. How did I find area bounded? Because it's the same process. How did I find the area bounded if I wanted the area between this one and that one? Would you say, Caroline, chat? And we know we use what? Yeah, exactly. If you have two formulas, it's going to be some sort of washer thing. And if you have one, it's just going to be a solid object. So if you have two of them, so like if you had this over here and I told you to find the area bounded and I just wanted this area, it would have been area of the top minus area of the bottom. This is the same exact principle. This is just now volume of the top minus volume of the bottom. So you treat the first one basically as a solid object, so that if you just had this, there's your solid object. You find the volume of this one, and then you want to do it again, and you say minus, and then you find the volume of the dashed one, and you're subtracting that out of the bigger one. Okay, so just treat it as two separate volumes. And now you want to say, well, which one of these is on the top? Which one of these is on the bottom? Use a little bit of logic and see what you can come up with. Okay, ready, go. Okay, let's see what we got. So first thing you want to make sense out of is that the one on top is the square root of x, and the one on the bottom, like we just talked about, is x squared. So this is going to be pi radius squared minus pi radius squared. Okay. And these are both going from 0 to 1. So you got the top one, you got the bottom one. Okay, so if we square both of these, now we've got pi 0 to 1. That's x minus pi. And then this is 0 to 1, x to the fourth. Okay, you've got some options at this point. Now you have to square these before you squish them together. Square, you'll hear me say this a lot with this problem. I don't know what, it's just the phrase we came up with. Square before you squish, because it's going to be easier if you squish these together and make one whole thing, but you've got to square these before you do it. Otherwise, in some other problems, you'll end up with a mess. And if you don't want to squish them together, that's cool too. We can just do two separate problems. Okay. All right, so let's just leave them separate for right now. This would then be pi, and this would be x squared over 2, 0 to 1. And this will be pi x to the fifth over 5, 0 to 1. Okay, so if we plug in 1, it's going to be a half. Plug in the 0, nothing's happening. So that's going to be 1 over 2 pi. So let's call that pi over 2. Minus over here, we're going to come up with, plug in that, that's going to be pi over 5. And the 0 again is going to not give us anything. And then if we were to put this into an answer, we could put these both over 10. So that would be 5 pi over 10 minus 2 pi over 10. And the correct answer to this problem was, in fact, 3 pi over 10. Okay. So if that's making sense, I feel comfortable in saying that I think you got enough out of the lesson that you're probably okay. And in reality, we probably did not need a 2-hour and 45-minute long video on that lesson. However, it was good for you to see somebody else teach some calculus and talk about a bunch of concepts. So I thought it was worth its time for you guys. So do we have any questions on that problem? This topic will be coming up in free response sometime in the near future. So we're going to be using it. It will be in multiple choice on your AP exam. It will likely make an appearance somewhere in the free response. So we will be revisiting this. Any questions?
Yeah, the guy in the video did it different from you, but I did it. I did it that way, and I still got the same answer, so it must work.
What did he? What's different? What are you doing? What do you mean by different?
He didn't break up the integral like you did. He just kept it like all one big thing.
Yeah. So that's what I was saying. Square before you squish. So if you want, once you square both of these, we can just call this pi integral x minus x to the fourth dx, and you're going to get the same exact answer.
Yeah,
that's the way you went. Yeah, it's entirely up to you on which way you want to go through it. This is actually cleaner, to be honest. Just make sure you square the functions before you squish them together.
Okay.
Any other questions? All right, then I would like to spend our last 20, 30 minutes here going back to something from last week, and that had been I said we were going to talk about this. Let me find it. Give me one second. Okay, so we had done A, B, C, and D last time that we had met. So I want to talk about E, absolute maximum. And this is a really important one. This is definitely 100% on free response somewhere. Find the absolute maximum. So before we get into this problem, which is a little more complicated, messy, let's do a quick recap because it's been a long time since we've talked about absolute extrema. Keyword, absolute. So if you remember this lesson from way back in the first part of the year, absolute extrema is endpoints and critical points into the original. Endpoints and critical points into the original. So now if you remember, I can give you something that looks like this. And if you only do a first derivative test, you're going to come out with 2 and 3. Whereas is 2 and 3 the absolute extrema of this graph? Absolute extrema is the absolute highest and lowest. Relative extrema is those hills. Now, the relative extrema can be that if we had a graph that looked like this. Now, in that case, the relative extrema is the absolute extrema. So we just don't know. So to figure out the absolute extrema, you're looking at the endpoints and the critical points, and we want to plug them into the original to see what we're talking about. So, for example, if you had a question that just said like f of x is equal to x squared plus 4x plus 3 on 0 to 3, and we want to find the endpoints and the critical points. So let's change that interval to -2 comma 3 because I'm making this problem up on the fly. So we're going to make a table, and you're going to plug in the endpoints and the critical points. The endpoints are given to you. How do we find critical points, guys? Take a derivative, right? So do a first derivative test. So f prime is 2x plus 4. Solve that out. X is equal to -2. I'm going to change this problem again because I'm still making this up as I go from -3 to 3 so that my -2 fits in there. But you get the gist of what I'm trying to show you. So you're taking the endpoints and the critical points, and we're going to plug them into the original. And then the highest point you get is your max, and the lowest point you get is your min. And that's how you find absolute extrema, right? So does that process make sense? Because we're going to translate that now into a free response problem. So let's explain that again. Endpoints and critical points into the original. And the reason for that is we don't know what the absolute highest and lowest is. We just know it's either going to happen at the endpoints or at the critical points, right? So that's what we've got for starters. And then you take the endpoints, table them, find the critical point or points, table them, plug it all into the original, and then your Y values will tell you the story. Does anybody have any questions on that? Okay, moving on. So let's now flash back to, okay, we're at part E. The function G is given by, let's just write this down. G of T is equal to -2 to T f of x dx. Find the absolute max on the interval -2 to 5. So first things first, I'm going to make a table, and I'm going to list my endpoints, -2 to 5. Easy enough. I have endpoints, and I need critical points. How do I find critical points? I find critical points by taking the derivative and setting it to 0. Well, what's the derivative? G prime of T is equal to, G is equal to integral F. So G prime is equal to F of T. And we're going to set that equal to 0. So now G prime of t equals f of t, and we're setting it to 0. So the question now becomes, where is f of t 0? I don't know. We need to find the graph of f of t, so give me 1 second to do that. Okay, here's our problem. So where is f, the graph is f, where's f equal to 0? At -1 and at 5. Well, we don't need to list 5, we've already got that, so it's going to be at -1. Does that make sense? Why I've chosen that point? We want endpoints, we got it, endpoint, endpoint, and we want critical points. How do we find critical point? Take the derivative, set it to 0. The derivative of g is the same thing as f. So where are these two things, they're the same, equal to 0? Well, I don't know anything about g prime, but I do know stuff about f, and f is 0 at -1 and 5. 5 was already an endpoint, so we're good there. So I'm going to toss -1 on the table. Does that make sense?
This is a really stupid question, but isn't f of t also equal to 0 at like 1/2?
Yes, I don't know why I overlooked that entirely. It's not a stupid question at all. Why did I not see that? I don't know. Because I've been up since 8 a.m. for the first time in 8 months. I was actually at TC today. Yeah, definitely 0 at 1/2. Don't know why I overlooked that one. Anybody have any questions on that? So we've got zeros at -1 and then the one that I didn't see for some reason. And now you're looking at this and you've got your endpoints and critical points. Now the process here, or the plan, is going to be to plug these into the original. What's the original? The original is up here, g of t. So we need to find g of 5, g of 1/2, g of -1, g of -2. This is going to get very annoying because you have to find all these areas. So you need to have remembered something now. And what you need to remember is that you already did parts A, B, C, and D in this problem. So you have lots of this stuff already figured out. So for example, -2 is easy. If I plug -2 in, what's the area from -2 to -2? 0. So because I didn't go anywhere. So that's 1 down, 1 to go. The next one's going to be, what's the area from -2 to -1? We already did that one. -2 to -1. That's going to be what? 1/2. Next one, -2 to +1/2. If you remember correctly, this one and this one canceled. So all we're really looking at is this one over here. And what was that area?
1/4?
Say that again. It cut out for me.
Was it 1/4?
Positive or negative?
Negative.
Negative. Yeah, that's what I was going to say. -1/4. And then we got one more we got to figure out, and that's -2 to 5. Now, pause, because if you look at the previous problem last week, we already did that and found that disaster. What was the area from -2 to 5 in that prior problem?
It was like 9.9 times pi over 4. I guess.
9 minus, wasn't it?
That's when we wanted to find the area from -2 to negative.
From -2 to 5?
To -7, actually. We subtracted it from, no, you're right. Yeah, that's okay.
Okay, so the part you were talking about is when we went all the way out to -6, right? So the part we had found though was 9 minus 9 pi over 4. Okay, so now looking at all this, we want to know what is the absolute maximum. So I think we can safely rule out that it's not -1/4. So I'm going to say no. And then it's not 0. So we're going to say no. You don't need to write no, by the way. I'm just doing this to eliminate what we're doing. All right. So then the question becomes, is it 9 or is it 9 minus 9 pi over 4? So what is 9 pi over 4? So 9 times, just call this 3 for a second, 3.14, but let's just call it 3. So that's 27 over 4. And 27 over 4 is really equal to 6 3/4, roughly. Either way, if I do 9 minus 6 3/4, it's going to be a little more than that because pi is 3.14. Either way, that we're comparing this to a half. 9 minus 6 point something, even if it's 9 minus 7, that's going to be a bigger number than the half, right? So the answer to this question is absolute max at y equals 9 minus 9 pi over 4 when x equals 5. Questions, comments, thoughts, where are we at?
If we were to write this on the AP exam, could we just like write out max, or would we have to write out maximum?
You want to use the word absolute max, but max versus maximum should not have any difference.
Okay, got it. I just don't know like what
I
I
think-
can abbreviate and what I can't. So
Yeah, I mean, if it's like super, super obvious, you're okay. I know you don't want to do because as BC. I know you want to try your best to write sentences out, but like max versus maximum shouldn't be a big deal. All right, any questions?
Quickly go over how we found the area from 1/2 to -2. Was that one that we'd already done, or do we just do that math in our head?
To say that one more time, from where to where?
1/2 to -2. When we did the area of the
Oh, yeah, okay. So last time we did one of these, so from -2 to -1 and from -1 to 0 are the same exact thing, plus and minus. So that just wiped out. So we were then just talking about this area right there.
great, thank you.
All right, give me 1 second. Let me dig up a problem that resembles what we just talked about. Actually, maybe we should just finish this assignment while we have it up. Let's just do that. That way we can be done with this. All right, so for part F, using G at T from part E, we want to know is the rate of change, that's telling you something very specific, increasing or decreasing at 3. And for part G, you have a limit question, which I've told you now what to do with a limit question in free response. So take a minute and just copy F and G down, and then I will change the slide to the main page so that you can use the information to answer the questions. So copy down F and G. Okay, we should have that all copied. And then let's go back to All right, let's see what we got. Using G of T, so let me recopy that down. We're gonna G of T is equal to -2 to what T? Okay, we want to know, is it increasing or decreasing? All they're asking you to do is take the derivative, plug in the value, and see if the answer is positive or negative. So G prime of 3 is equal to, what would that be equal to? Isn't that just equal to F of 3? G prime would be equal to F. So G prime of 3 is F of 3, which is equal to, somebody that did this, is that a positive or negative value?
It's negative.
It's a negative value. Therefore, it's decreasing at T equals 3 because G prime of 3 equals F of 3, and that is less than 0. All right, see what's going on in part G. Part G is our L'Hopital's rule. I'm assuming, at least it's a limit question. So when you plugged in 1, did you get 0 over 0?
No, I got E -3 over -28. There's no need, I think, for L'Hopital rule. Actually.
Yeah, I did not get 0 over 0.
Interesting. Okay. Usually that's the case with a limit question and free response. All right, let's plug it in, see what we get. So that's e to the first minus 3f of 1 over vp of 1 minus cosine of pi. All right, so that's E minus, what's F of 1, somebody? That should be right on the graph.
It's 1.
F of 1 is 1.
Yes.
Okay. Over, what was VP of 1?
Negative 29.
Negative 29 minus cosine of pi is negative 1. Huh, wonder what they were going for here. E minus 3 over negative 28. Find the limit, and yeah, that's all there is.
That's a
Interesting.
point, actually, in the test.
Yeah, not much to do on that one. Huh. Normally, when you see a limit question, like 97 out of 100 limit questions you would come across in free response is going to be L'Hopital's rule. Guess that is proof that you should check to make sure it is what it is before you set it to the next step, because that would have been my instinct too, Caroline. But all right, anyways, any questions? Okay.
What was the justification for part F again?
Part F. So we said,
Thank you.
we said, if you're finding if something's increasing or decreasing, that's just is the derivative positive or negative. So we took the derivative and plugged in 3. And whenever I plug in 3, G prime is the same thing as F. G equals integral F, so G prime's F. And since that was a negative value, we said it's decreasing at T equals 3 because G prime of 3, which is F of 3, is less than 0.
Perfect. Thank you.
Sure.
This might be a silly question, but when is it again when you have to compare the original to the derivative?
So,
Like for some reason I was thinking that if you were finding, like, I'm getting myself confused, but when you're finding if something is increasing or decreasing, you have to compare the original equation, like answer, to the derivative answer, and then compare the signs. Okay, speeding up or slowing down. That's exactly.
yes. Okay.
Yeah.
That one is when you're doing now speeding up or slowing down, that's velocity and acceleration that you're comparing, not necessarily the original. That's why I think you threw me off there. So that's comparing the first derivative to the second derivative. So the only real time that you get involved with both of them at the same time is when you do what we did earlier tonight, which was absolute extrema. That's when you have endpoints and critical points. And the endpoints and critical points all go into the original, and then you figure out the Y values from there.
Okay, yeah. Sorry, I didn't mean to confuse you.
Ah, you're good. Any other questions?
Sir Baker,
Yes.
at F3, should we find the slope or the exact value of F3? Because
We don't care. We just want to know if it's positive or negative.
that's positive, like the F3 is positive on the graph.
Uh-huh.
The slope is negative, but F3 is positive, like exact value.
Well, why'd you guys tell me it was negative? Hold on. Let me look it up. F of 3. Oh, yeah, guys, we screwed up here. F of 3 is positive. F of 3 is greater than 0, right? So this wouldn't be decreasing. This would be increasing. We want to know G prime is equal to F of 3. We want to know, is F of 3 positive or is F of 3 negative? So now if it asked F prime is negative, but we just said regular old F, that's the Y value. So the Y value corresponding to F is a positive number.
And it's not F prime because it's
Yeah, this whole question's asking about G.
G. Okay.
G, it gets confusing because you have to connect all these trains of thought, but G equals integral F. It's asking you, is G increasing or decreasing? So if G is increasing or decreasing, you're saying, well, G prime is equal to F. So G prime of 3, which I'm interested in, is the same thing as F of 3. And F of 3 is a positive number. Therefore, and then you reach your conclusion from there. Okay. All right, guys, so that's 8 o'clock. Give me a second to scribble some names down here. Anybody going to school tomorrow? No, nobody? Just me, okay. All right, well, if you are in school tomorrow, make sure you swing by and say hi and possibly introduce yourself if I've never met you before, so that I'm not awkwardly asking who you are, even though I've been talking to you for the last 9 months. I've only been looking at small windows on a chat screen. So if you are coming by to school tomorrow, I'm in B236. So if you are making your way out there tomorrow, come by and say hi, introduce yourself. All right, give me 1 second, guys, to scribble
Baker,
attendance
is there
down.
ever be, like a 3:30 class again, or are we?
Well,
just-
I'm waiting for them. I'm waiting for them to tell me what I'm allowed to do. I'm cautiously optimistic that we're going to do some in-person sessions after school every day. The only thing is that, do you guys drive? Do you have your own way home? If you have your own way home, I'm pretty sure they're going to let you guys, Kate, I'm pretty sure they're going to let me have you guys come in after school, like up to groups of like 10 or so of you. So I think we're going to start doing in-person stuff after school for the 3:30. And then if you can't make that, we'll have the 7:30 each night. Okay.
And just to make sure the people at home can still join the 3:30 session on Zoom.
Hopefully. I went to school today and I was there for like 6 hours and it was a big disaster. They gave me a overhead document camera, which is the same thing I have at home, except theirs was completely broken and doesn't work. So that was fun. And then, so I'm not transporting this one from home to school every day, basically, is what I'm trying to avoid, because I need this at home at night for tutoring. So once I get one that's working, I would be planning to do the 3:30 one in person, but I would still have the computer. I'm pretty much just making this up as I go, to tell you the truth. I'm going to do my best to have as many options as I can for you. There's not a whole lot of guidance at school right now. There's just stuff happening everywhere.
Awesome, thank you.
Yeah. All right, 3 more. Syed, Violet, and Will. All right, guys, I got everybody's names. Have a good night. If you're in school tomorrow, my room is B as in boy 236. It's off to the corner. Some of you know where it's at. Some of you will find it. Come say hi if you're in school tomorrow. I will talk to you guys soon. Have a good night.
Thank you. Have a great night.
See ya.